Awesome. So for today, we're going to be going over two GIZMOS simulations. So for the ones watching, if you can go to GIZMOS, that would be great. And we're going to be on the energy conversions, okay? Now, for the rest of us who are here ready to go, now, GIZMOS energy conversions, everything we learned in this simulation was about transferring energy, right? So how energy can transfer from one form to another, right? That's what we learned. If you go to information mode, you can actually click on each section and it will tell you a little like summary of how the energy is transferred, okay? So it's a really good, really cool way of just seeing the information right there. And if you go to path mode, that one actually tells you different paths you can take to provide that form of energy. Okay, so let's spend some time right now. Okay, let's work on the first one. Can someone draw for me a path? Let's spend 30 seconds drawing me a path on how to have energy for the stereo. There's different paths for it. Okay, so let's spend 30 seconds. I'm gonna put 30 seconds. And give me a path on how we can get energy for the stereo. Okay, 30 seconds. About 20 more seconds. Show me where the stereo gets its energy from. If you think you have the answer, for the ones on the Zoom session, if you can just type it in the chat box, publicly or privately. Awesome. So there's very different ways. So we do the solar panel and the sun. Boom, simple, right? The sun transfers energy to the solar panel, and then the solar panel transfers energy into electricity. Pretty simple, right? There's other paths though, as my students who are here are saying. Sarai said, the sun to the corn to the ethanol plant. So the sun grows the corn, then the corn uses its energy. It converts it into basic ethanol, which is a form of energy. It's a form of liquid. And that energy, that ethanol gets transfers into stereo. Awesome. There's actually another one as well. If we go into the stereo, into the dam, and then it's powered by the water and provided by the sun. So the sun heats up the water, which transfers energy to the dam, and the dam keeps moving back and forth, and it provides energy for the stereo. Awesome. Let's do another one. Let's do the person. How do we as humans, how do we get energy? How do humans get energy? Let's spend about 30 seconds on that one as well. And once you have the answer, please type it in the chat box. How does a human get its energy? So let's see. We got some answers in the chat box. It says sun, corn, chicken, and human. So the person eats the chicken eats the corn, and the corn gets energy from the sun. Very good job. Yes, it seems like that's probably the most straightforward answer in a way. Maybe. No, yeah, that seems to be the most straightforward answer. Yes. So very good job on that. So sun, corn, chicken, and human. Thank you, Jasmine. Yes, sun, corn, chicken, and human. So the key thing to learn about this, it seems very simple because energy is pretty simple. Okay, so just know that energy is transferred. The law of conservation of energy states that energy cannot be created, it cannot be destroyed, it can only be what? Transferred. So everything is transferred, okay? That is the biggest key we need to know about that, okay? That's basically all there is to this simulation. As long as you understand that energy is transferred between different forms of energy, whether it's mechanical, let's say whether it's mechanical energy for the plant or for the dam, whether it's wind energy from the wind turbine, whether it's solar energy from the solar panel and from the sun, whether it's electricity through the stereo, the lights, and the toaster, whether it's actual functioning energy from eating food from the person, so like from the nutrients and the proteins that gives us energy, whether it's the sugar from the corn. So everything has energy that gets transferred, okay? So that's what we're going to do for today on this simulation. Let us move to the next one. So if you go back to your classes, go to the energy of a pendulum now. Now let's go to the energy of the pendulum, and this will be the last thing we'll be doing. Playing again. Awesome. So you're in this simulation, the energy of a pendulum. So if you haven't done so, spend some time playing around with this because it has more schematics and more characteristics to it and more functions. So, but for the ones who are ready to go, let's spend some first thing. Let's rearrange our description. So if you're in, please go to the description box, which is the one right here. Click right here. On the gizmo status, let's actually go all the way down to 0 degrees. Okay. 0 degrees. So make sure your degrees is 0. Okay. So make sure it looks like mine, 0 degrees. Okay. Now, if you have 0 degrees, let's click play. Let's play it. So go down here where it says controls and let's play it. Obviously, nothing's happening. It's not moving, right? If you go to table, the potential energy and the kinetic energy is what? 0 joules. Nothing's happening. The bar chart, nothing's happening. The graph, nothing's happening. So basically, nothing's happened because we haven't built up the energy. No energy has been building up. There's no potential energy because nothing's being stored, because nothing's moving. Nothing's being transferred. So let's see what happens if we click reset. Now let's make sure you click reset, which is a little button with the arrow, kind of like going like a crooked arrow. And let's go up to, let's say to 20. Let's go to 20 degrees. So click all the way up to 20 degrees, okay? So gizmo status, 20 degrees. You keep the same mass, length, and gravity, 0.5, 2.0, 9.8. So you have to, don't mess with that. You don't have to mess with that. Let's click play. And now it's moving back and forth, right? Now it's swinging back and forth. Let's check our table. Kinetic energy and potential energy is being transferred, so that's good. Let's click on the bar chart. Look at that. Potential energy and kinetic energy is being transferred back and forth, right? Look at that, back and forth. If we check the graph, kinetic energy and potential energy are being also transferred back and forth. Look at that. You see that? When potential energy is at its max, like if I pause it, when potential energy is at its max, kinetic energy is at its minimum, and vice versa. When kinetic energy is at its max, potential energy is at its minimum, right? So if you click play again and you try to stop it at the very lowest point, so let me try to stop at the very lowest point. Oh, that didn't work out. Let me try to stop it. Oh, let me get a little bit closer. A little bit closer. There you go. Look at almost perfect. As you can see, the ball is stopped at the way bottom. I stopped it at the most bottom point. So according to the bar chart, my kinetic energy is at the highest. I have a max kinetic energy. And that means, what does that mean exactly? And that's okay. So basically, if you click on the numerical values, kinetic energy is at 0.6, which is the total energy. The reason kinetic energy is at its maximum point at the lowest point of the swing is because it's moving the most. Remember, kinetic energy, you're releasing energy and you're moving. So you're moving the fastest at the lowest point because You build up all that energy swinging up. So when you swing back down at the lowest point, you're swinging the fastest. At that point, you have the most kinetic energy. But what happens if I click play and I try to stop it at the highest point? Boom, right there. If I stop it at the highest point, what does that mean about potential energy? Yes, so we're getting some answers right here. Is potential energy, it's at its highest because that's where it's storing energy. It's storing the most energy. And at this specific point, let me put a little arrow. Woo! Oh, sorry. Woo! At this specific point, potential energy, at this specific point, the ball is not moving because it's as high as it can go. It's not moving because it's as high as it can go. That means it's still. It's resting in the air. It's not moving in the air. So that's where it's storing the most energy, the most potential energy. Awesome. Thank you so much, Sarai, for answering that question. Now, if we click play again, you can see that energy is being transferred, right? Back and forth. Let me make this a little bit bigger. It's being transferred back. Maybe I can make it a little bit bigger. No. It's being transferred back and forth. Why is total energy the same, though? You see that? Like, why is total energy not changing? So let's try answering that question. Why is total energy not changing? Why is the bar not changing? Why is the graph just the same, like a little straight line? Why is it the same like that? Why is total energy not changing? Again, look at you. Just come out with these answers. Love it. Awesome. Thank you, Sadi. Yes, because both kinetic energy and potential energy add up to make total energy. So if I stop at any point, let's say I stop it right here. Potential energy is 0.5 joules and kinetic energy is 0.1 joules. So what's 0.1 plus 0.5? 0.6 joules. What happens if I click play again and stop it again? Now potential energy is 0.6 joules and kinetic energy is 0 joules. So what's 0.6 plus 0? 0.6 joules. So yes, the reason total energy is not changing is because it's the total. It's the sum of potential and kinetic energy. So it's never going to add more. You're never going to take away. You're never going to destroy it. It's always going to be transferred. So total energy is pretty consistent. That's why in the graph, it's just a straight line. It's a straight line in the graph because it never changes. It's always constant. Awesome. Very good job. Or let's press pause and let's reset it. Let's reset our values. Go back to description and go all the way up to 40 degrees, okay? So once again, go to description, make sure you reset it, and go all the way up to 40 degrees, okay? All the way to the right to 40 degrees, okay? And then click play. So now there's more momentum, right? Because you actually held it up higher. So not swinging back and forth. If I go to the table, you can see the energy right there being transferred back and forth. If I go to the bar chart, look at that. Same thing. Now it's more energy though, right? Since I held up higher, there's more energy to it. As opposed to my 20 degrees, I didn't have as much energy. But the higher I hold it, the higher it starts, the more energy is going to have to transfer. At this point now, it's instead of 0.6 joules, now it's 2.3 joules of total energy. But the same thing, the same rules applies. Potential energy is at its highest, at the highest point, and kinetic energy is at its highest at the lowest point. Same thing. The same rules apply. If you check the graph, look at that. The graph, still the same. They're off of each other, okay? They're opposite of each other, still the same. Nothing changes. The rules still apply, okay? Look at that. Look how pretty that looks. Recording. Okay, that's the extent of everything you need to know for the test. Don't be afraid of the test. The test is a little bit long, but the things we've gone over is not supposed to confuse you. It's a pretty straightforward, hopefully. Once we get to the next unit, that's when things are going to pick up. But this unit 1 should be a pretty good boost to your grade if you feel like you haven't done that well in the past. So definitely take the test and try your best, okay? Definitely try your best on the CER statement question. But that is the extent of today. So I'm actually going to stop my recording for my async recorder. So if you have any questions, please let me know. I'll always post on Piazza, email me or Google Classroom or Go Guardian, and I'll be there, okay? Adios.